So this was one of the things I was going to do the other night when I had that optional meeting, because this isn't easy stuff, and how do you do it? So first thing you got to remember is the fundamental theorem of algebra tells us, hey, you take a look at for a polynomial. Let's do this a minute here. Let me get a pointer going. Take a look for a polynomial. You look at the largest term. You look at that leading term, that degree of the polynomial. That tells us how many zeros there are going to be. Now, it might be there's only one of them, like x to the fifth, right? That has 1 0. Maybe you don't know that. Maybe I better do that for you. Y equals x to the fifth. Fundamental theorem of algebra says there's 5 zeros. I'm only seeing it cross the x-axis once, and I know because it's x to the fifth, that's the end of the behavior, right? Because x goes out to positive infinity, y goes to positive infinity, and as x goes out to negative infinity, y goes to negative infinity. So it's not going to turn around and head back, right? We know that. We can prove that with calculus, but we don't need to go there for this. So I see 1 0. So that 0 would have multiplicity 5. And that takes care of the fundamental theorem of algebra. Okay. I hope I said algebra, not calculus, the first time. That's a different fundamental theorem. So anyway, so there's x to the fifth. And so then this one, it's got a bunch of other terms, but the degree is 5. So we know there's supposed to be 5 zeros. So I graphed it. I mean, you could use that Cauchy's theorem and Descartes' rule of signs, and Descartes' rule of signs is a great thing to help you, but you don't need to know it. But it's just in theory, and if you get all this stuff down, go check out Descartes' rule of signs. I mean, Cauchy's theorem, I don't know if I'm saying it right. That works too with the bounds, but we don't need to do that in 2022. With this graph, I am seeing it touch the x-axis 5 times, now 4 times, but it's bouncing here at x equals 3. So there's supposed to be 5 zeros, 1, 2, 3, 4. So because this bounce acts like x squared, it has to have multiplicity 2. So remember that thing from 5.3.3 where the multiplicities? That's why it's got to account for those things. So I mean, we could. I mean, if this was a open math question, actually, I think it is a open math question. But so I could just do this. I could, okay. So I know that this thing factors to. Well, I know there's a leading coefficient of 6. I know it factors to x plus 3 because this is minus 3, right? Gotta change the sign. When x equals minus 3 plus 3 is 0. And then it's what, now this is weird. This is not a nice integer. However, that's negative 2/3. Okay, so I could write x plus 2/3. That's a little awkward with a fraction there. So what we'll do is write, nope, we won't write that. How do I undo? We'll do 3x plus 2, because if I solve that for x, I get my x equals negative 2/3. And then there was, what's this one? Is this a positive 2/3? No, it doesn't look it. It looks different. No, that's a positive 3. Oh, I'm sorry, right there. That's 1.5, right? So 3/2. I could write x minus 1/2, but be better to write x, it's 1.5, right? So x minus 3/2. But again, we can do that same trick. 2x minus 3, and there, that way I get my 1/2. And it looks more normal, like we usually see when we see a factor. And then of course that last one is x minus 3, and we get to square that because it's bounce. And there's 1 0 2 0 3 zeros, 4 5 zeros, and that's how that would factor to without a whole lot of work. And I didn't have to do any synthetic division with this because I could see the 5 zeros right there. Now, on the exam, I'm not going to ask you that. So you're gonna get have to do a little more work with that. Just a minute here. I'll create one here that we'll need to do more work. So here's a polynomial I just created, and I see 4 zeros. So we know there's no complex zeros, and we'll do one of those next. I see nice integer values at x equals 5. I see another nice integer value at x equals -3. And then I get these decimal values. And those aren't nice decimals like 0.667 or 1.5. Those are probably irrational. I'll tell you, they are irrational. So they're like a square root of 3 or something like that. Okay. So we need to do a little more work with this. And since we know there's supposed to be 4 zeros, I see the 4 zeros, but 2 of them are going to be irrational. So they're going to have square roots with it. So here's where we got to do some synthetic division. We got to do some work. And it's not a lot of work. So I'm going to remove this 0 to bring this down to a smaller value. And if you remember smaller polynomials, I'm going to do some factoring. So I've got, let's see, what is it? I've got 2, I've got 6. I'm not missing any powers of x. No. So 2 and 6 and -48 and -154 minus 30. And remember, you bring down the 2. When we multiply, we get -6. So that's 0. And 0 times -3 is 0. We're going to get -48. And -48 times -3 is positive. Oh, let's see. What's 120 plus 24? 120 plus 24 is 144. Who would have known? And that's positive 144. And that's 10 left over, -10 left over. -10 times -3 is positive 30. And the remainder is 0. Of course, we knew it was going to be 0 because that was a 0, right? Remember, another name for synthetic division is synthetic substitution. So we evaluated that polynomial at -3, we get 0. That's because it crossed the x-axis. So now we're going to get rid of the 5, because right now what I've got, so let me make sure you catch this. So what I've done right now, I've got x plus 3 as a factor. Remember, we're going to change the sign, times 2x to the 3rd. It was x to the 4th, but we divided off an x value, right? So 3rd plus 0x squared minus 48x minus 10. And yes, I could factor, it almost looks like the factor 2 out, and probably I should have done that ahead of time. I spaced it. Let's do that right now. Pull those numbers down. 2 times x plus 3 times x cubed minus 24x minus 5. Okay, so that's what that factors. If it didn't factor anymore, we would be stuck there, would have to do some other stuff, but it does factor. So we're going to keep going. I know it factors further because of the x equals 5. That's a nice rational value. So we know we can keep going. So what we're going to do is, instead of, yes, I can take care of the 2 right now, but why do more work than we need to? What I'm going to do is I'm going to continue my synthetic division right here. Why don't I change the sign? Sorry, that's a teacher question. Because we're evaluating this at x equals 5. Okay, if I had been given x minus 5, then I would have to change it to positive 5 and evaluate it, right? See, this would be so much better live. 2 times 5 is 10. Add, we get the 10. 10 times 5 is 50. Add those, you get 2. 2 times 5 is 10. And we get 0. Of course, we knew it was going to be 0. And we remember that 2 we can factor out. I'm going to get rid of that at this point. So 2x plus 3 times x minus 5 times, remember, I divided each of these by 2. And I divided off an x twice. So that leaves me an x to the 2nd power. So x squared plus 5x plus 1. And at this point, we could try to factor it, but what multiplies to give me 1 that will add to give me 5? Well, nothing. And of course, I knew it was going to factor because those aren't nice numbers. Those are the weird decimals. So we're stuck using the quadratic formula. And remember from section 2 or from earlier in the earlier years, negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is 5, c is 1. So let's see, negative b plus or minus the square root of b squared. I never write 5 squared or the b squared. I always do the squaring. It helps me from making mistakes. The negative 4 times 1 times 1, 4ac, all over 2 times a. So we get negative 5 plus or minus the square root of, let's see, 4 times 1 is 4. 25 minus 4 is 21, all over 2. And let's see, 21 only factors to 7 and 3, or 21 and 1. So that doesn't factor any further. So that is, so my other two answers are x equals negative 5 minus the square root of 21 over 2, and x equals negative 5 plus the square root of 21 over 2. And I'm not going to do this, but if I grabbed a calculator, that's what that's equal to. And if I grabbed a calculator, that's what this is equal to. Check it, make sure I didn't screw up, but I'm pretty sure I'm okay. All right. Now, if they want me to factor this polynomial, so there's some things we can do with this. If they wanted me to factor this polynomial, the best I can do would be here, unless they said linear factors. And if they want linear factors, they're being obnoxious. What we'd have to do is here, I'll just come back and fix my work. You'd have to say minus that thing. Remember how we change it? We're changing our sign. So that'd be a factor. Pretty awful. And then this one would also be a factor. And yes, you can do some cleaning up. You probably would want to do some cleaning up, but I will never ask you that on an exam. Okay. All right, so we get the factoring. We learned how to factor this. We learned how to break it down and find all the zeros. And we didn't have to do anything very, very fancy with this. Go check out Descartes' signs. That will tell us that there's about the number of positive, number of negatives. Maybe I've made answers and possibly the number of complex answers, but this doesn't have any complex answers. How do I know this doesn't have any complex answers? This polynomial? Because it crosses the x-axis 4 times, and the fundamental theorem of algebra says this should be 4 zeros, and we've seen the 4, so there's no complex answers. Now, without a note, just a minute here, and I'll make one that does have complex zeros. So here's a polynomial, 4th degree. There should be 4 zeros. Right now, I'm only seeing 2. How do I, when I know the end of behavior as x goes out to positive infinity, y should go to positive infinity. As f goes out to negative infinity, y should also go up to positive infinity, because it's an even powered polynomial, right? It'd be nice to make sure. So I don't know, I'm doing this with Desmos, so I don't know if you know how to do this. If you click on the gear, I see, I'm going to leave this at negative 10. And I did this a little earlier, so I kind of cheated a little bit. What I did is I zoomed out till I found out where it turned at the bottom. That was like at negative 800. So I'm going to do like negative 850. And there's no way I knew that, other than I cheated a little bit ahead of time. And I'm going to make this be 1,000 just to see what it looks like. Yeah, it looks good. And that actually looks pretty good, doesn't it? I see some wiggling going on. I see it crossing the x-axis here. I see it crossing the x-axis out here, and I don't see any other zeros. And I'm out at I'm at 8. And then we're up to 1,000. I mean, it's possible it turns around again, but I would say it's probably pretty safe. Well, I know I made it so it didn't, but it's a pretty safe bet that's not going to turn around. For one thing, if it turns around again, it might have to go all the way through the x-axis and back up, and that would mess up the zeros. But I don't know. We'll try it and see how it works out. So I see 2 real zeros. I see there's supposed to be 4 of them. Let's use synthetic division, get rid of them. And of course, it's similar to what I did before. I just kind of tweaked the last question. And where's my pencil? Here it is. So I see everything's an even number. So I'm going to divide everything by 2. Factor out that 2 plus 3x cubed minus 15x squared minus, what is that, 85? No, 95? 95 minus 95x minus 150. So now let's do some synthetic division with those smaller numbers. -3, what do we got? 1, 3, -15, -95, -150. As long as I didn't make a mistake up there. I don't think I did. We'll find out. I know it's supposed to be 0, so we'll see. 1, so that's -3 is 0, and then 0 and -15, and that's +45, and that's -50, and -50 times -3 is +150. We get 0. There we go. And now let's get rid of the other 0 at 5. So we get 5, we get 5, we get 25, we get 10, we get 50, we get 0. So I'm left with x plus 3, or 2, x plus 3, x minus 5, and then x squared plus 5x plus 10. Okay, then we try to factor that because factoring is so much easier than anything else. And let's see, what multiplies to give me 10 that allowed to give me 5? Well, 10 and 1 and 5 and 2, neither one will give me 5. So I'm stuck using the quadratic formula. So A equals 1, B equals 5, C equals 10, -5 plus or minus the square root of 25, 5 squared, right? Minus 4 times 1 times 10, all over 2 times 1. So we get -5 plus or minus the square root of, let's see, 4 times 1 times 10 is 40. 25 minus 40 is -15 over 2. And 15 is 3 factors of 15 are 3 and 5. So we can't do much with that. I have the negative, so I'm going to bring that out as an I. So -5 plus or minus I square root of 15 all over 2. Something I didn't do with that last example. I could say -5 over 2 minus square root of 15 over 2i. I mean, I could write it that way. And I could write that as -5 over 2 plus the square root of 15 over 2i. Okay, so that's what x equals, and we can't do much with those because of the I. We kind of got to just leave it alone. I mean, we could write the factors. If they wanted it as linear factors, like sometimes math wants that. I would write x minus, and then write -5 over 2 minus root 15 over 2i, and then x plus, another x minus -5 over 2 plus, that's where the plus is coming in, over 2. At least I caught that, huh? So that factor, that factor, and these two factors should be the linear factors. This is perfectly, if I told you to factor it and that's what you did, fantastic. I'm going to do one more situation just because the textbook throws some problems like this at you. Okay, I wrote this one out factored because you've already seen seen how to do that, and you see how we have, let's see, this is supposed to have, I don't know the degree of that polynomial. I'm hoping that you understand that, oh, I do know the degree of this polynomial because all I have to do is, let's see, 4x to the 4th times x would be x to the 5th times x would be x to the 6th. Remember how you add the exponents? So that's a 6-degree polynomial. There's supposed to be 6 solutions. I'm only seeing 1, 2, 3, 4. So there must be 2 complex solutions in this mix, okay? The other thing I'm going to show you, I'm not showing you this so you can cheat, okay? I'm doing this, showing this to you so that you have some tools to help you learn, okay? Because I mean, sure, you can get through this course doing all kinds of these calculators, but you're going to not do well in calculus if that's the case. And I mean, that's the goal. You're taking pre-calc. Why would you put yourself through this course and not take calculus, right? So it is photo math will do things like this. I don't know if you get that in your phone. It's okay. It's a little, it does some wonky things sometimes. This symbol lab the kids showed me years ago at Oxbow. This is a great calculator too. And use this as a check. Use this as a check on your work. Don't do it with exams, but don't tell me if you do, right? I mean, I want you to do well with this, and I want you to do, but also, I mean, and you should be able to expand a polynomial by hand. That's not ridiculous. But when you're trying to do something quickly like this, see how fast that is? Isn't that amazing? And there, see how it's a 6-degree polynomial? We knew that without even having to do this thing. The other thing I'll show you while we're here, what if you wanted to factor something? You can say factor, see how it copied. Well, it did copy well. And it should take us right back to the other thing. Sometimes it does wonky things, and this one didn't, okay? In fact, see how I took it down a little further than what I did and what we did? So that's something I was gonna show you right now. Okay, so it didn't do something too wonky here. So how about this x squared plus 5, x squared minus 5? Let's go back and look at my Desmos graph. Where's that coming from? Well, I'm hoping you remember the difference of 2 squares. Like if I told you factor, or your algebra 1 teacher, algebra 2 potentially, if they said factor x squared minus 25, you would say, oh, that's x plus 5, x minus 5. Difference of 2 squares, right? And x squared plus 25 won't factor, right? That's not the sum of 2 squares. That will not factor. The other way to think about that, if you subtract 25 from both sides, I'm going to get the negative 25. Can't take the square root of a negative number without introducing imaginary numbers. So yeah, it won't factor. Okay. So how about this one? We have x to the 4th. Well, that's a square. It's just that it's x squared times x squared. X squared, and then the square root of 25 is 5. So x squared minus 5, x squared plus 5. See where they got that in the mix. So we've got factors of negative 3. We've got a factor of positive 5, and then these numbers here must be the square root of 5, right? Because I know that x squared equals 5. So x equals plus or minus the square root of 5. So, I mean, I'll leave it to you to go grab a calculator and make sure that's right. I'm pretty sure. I'm pretty confident it is. Well, I know negative 2 times negative 2 is positive 4. So a little bit more than that would be 5, I would believe. Okay, so that's where that's coming from. Now we get the 2 imaginary ones. Now, we could do a quadratic formula with this. We could say a equals 1, b equals 0, c equals 5, except it's a lot of work when we could just say x squared plus 5 equals 0, x squared equals negative 5, x equals plus or minus the square root of negative 5, or x plus minus I square root of 5. So there's our other 2 answers. Now, this wouldn't be bad to write as a set of linear factors. I could write it as 2 times x plus 3 times x minus 5 times x minus the square root of 5, x plus the square root of 5, and then x minus I square root of 5, and x plus I square root of 5. Notice 1, 2, 3, 4, 5, 6 terms, a 6-degree polynomial. Makes sense. Okay, I know this is only one example of each. If you want some time, grab some time with me. Remember, if you want some live help with me, so you can ask some questions. I'm probably going to put out a survey and ask what evening or times work best for everybody. But here, let me just come back into the courses so I don't flash confidential stuff up. Let me clear all my. How do I clear? Here it is. And remember, the front page of the course, you can use that calendar, set more calendar, and book some time with me. Remember, you got to plan ahead by 12 hours. I mean, you can always email me and ask, like today. You're going to see in a minute here. Like there's nothing available today. You can't sign up for anything today. You can only sign up for 7 p.m. tomorrow. Oh no, today's Friday. Sorry. I've only got 7 p.m. and 7:30 p.m. The reason those are available is because it's not 7 a.m. yet. Isn't that ridiculous? I'm up at 5 doing math. And so that's why you get to plan ahead by 12 hours. I could go tomorrow, I get a ton of time. I might block some of this out. So I like to plan my, I like to have some time. I'm gonna probably take lunchtime off. In fact, I did take lunchtime off and dinner time off already. So, but all that. Now the other thing with what I'm saying, like even though you can't sign up for something today before 7, I'm not all booked up today. So you send me an email if I see it, and if we can connect, we can try to meet. I take Sundays off. I know I've recorded this in another video, but I take Sundays off from live help. I'll do work in the morning, but I'm offline noon on Sunday. And then Monday's available. Monday, then Tuesday, Wednesday, I'm just doing some evening shots. And then Thursday, Friday, Saturday, I try to I'll make a lot of time available. If we gotta adjust this summer, I will. If it looks like it's gonna be a rainy day, I might open up some more time on Wednesday, Thursday, Friday. And conversely, I might, if I'm gonna get busy, um, I might block out some time. But you won't if and then occasionally you've made some appointment with me and something comes up and I'll have to cancel. Doesn't happen often, but it does happen. Okay, yeah, and these are great. These are just one-on-one sessions. If you think you're gonna need a lot of help, book 2 together. I wouldn't book more than 2. After about 45 minutes, people start getting tired and their brain's getting full and they need to go take a break and do something. So, 30-minute bite is a nice size. Okay. All right. Let me know what you need.